Hey guys, welcome back. Today we are going to go through transformations of graphs using matrices. And the first thing that we will need to go through is understanding what a matrix is. It's essentially, if you look over here, it's a form for listing numbers, and we find the position of these numbers using rows versus columns. So you can see this is an example on the side. There's also 2x3 matrices, 3x2 matrices. So you can just add a bunch of your numbers in, which are your lists, okay? Now, you can also add and subtract matrices. You can perform the order of operations. So something like this is very simple, okay? You have a 2x2 matrix, and you just take each number that is at the same position and you add them together. So you get 2 plus 1 is 3, 4 plus 2 is 6, 6, 2. Okay, and the same goes for subtraction, except this time the numbers are the same positions, you're taking them away. Now, what you can also do with matrices is multiplication. So what you have to remember is always just row by column. So the reason for this is C1, C2, R1, R2, is because what we're trying to get is the output value over here in the star. And you can see the star is under R1, C1. So what I'm doing is I'm timesing R1 by C1. So what you get is something that looks like this. So I have 1 times 2 plus 2 times 3. And then the second one in C2 will be, so what position am I at? I'm at R1, C2. So I'll use blue this time. I'll do R1 times C2. So this will be 1 times 1 plus 2 times 4. And then you just keep going. You have the next one will be 4 times 2 plus 1 times 3. The next one will be 4 times 1 plus 1 times 4. And then that is your matrix. So this is multiplication of matrices. Now, how this ties into the whole transformation thing is the fact that we can represent coordinates in the Cartesian plane with matrices. So for instance, if I have coordinate 1, 2, I can let this is my x value, this is my y value, and then I can denote the coordinate with the matrix 1, 2, okay? And what you can do with this, now that you can turn it into a matrix, is you can transform the matrix, and you can see how neither of these two have a comma or an apostrophe because they are the original coordinates, okay? And once you change them, we call it the image, okay? And then you denote it with these little apostrophes at the top, okay? So let's start off with a reflection in the x-axis. So we know from previous videos that this has an impact on the y value, okay? So if we're looking at the x value, the new x value or the image, we know that there will be no change to the x value. It stays the same because we're only affecting the y value. And since we're only looking at the x coordinate, there will be 0y, okay? Now, reflection in the x-axis, we know that once again, you're negating the y value, so that becomes negative y. And since we're only dealing with the y coordinate, it's 0x. So now I can write the matrix as 1, 0, 0, negative 1. And this is our transformation matrix. Transformation matrix for a reflection in the x-axis. And what you can do is, if you want to change a coordinate by reflecting it in the x-axis, all you have to do is plop this transformation matrix in front of the value that you want to change or the coordinate that you want to change. So I have 2, negative 3. And if you multiply it out, what you get is the image coordinate. So once again, row by column, this should be very easy. It's just 1 times 2 plus 0 times negative 3. And then you have the next one, row by column. You have 0 times 2 plus negative 1 times negative 3. And this gives you 2 and 3. So obviously you can see that it has had an impact on the y value by negating it, which reflects a reflection in the x-axis. And so the next one is reflection in the y-axis. Once again, we know it's a change in the x value this time. So we know that this creates a negative x, and then the 0y is because we're dealing with the x coordinate only, and then the y value doesn't change, and the 0x's because we're only dealing with the y coordinate. Now the transformation matrix would obviously be -1, 0, 0, 1. And since we've already got it in this form where it's like x and y, it's very simple to come up with the matrix itself. Okay, next one, dilation from the x-axis, or this can be parallel to the y-axis, whatever your book says, but most of the time you'll see the most common one is dilation from the x-axis. And just to recap, this means that we keep the x-axis the same and we're stretching or shrinking the y-axis, and then the graph changes along with that. So obviously, if we're stretching and shrinking the y-axis, then we are changing the y value. So what happens here is if I say dilation a factor of a from the x-axis, we know that this has an impact on the y value, so we times it with the y value, and then this is 0x, and then this will be, oops, the x value doesn't change, it will be 1x plus 0y. And so obviously our transformation matrix would just be 1, 0, 0, a. Dilation from the y-axis, same sort of idea. We are changing the x value, therefore it becomes ax plus 0y, and this would just stay the same at 0x plus y, 1y, okay? And one thing I'd like to note is that you can see how the image is like an equation based off of our original functions. These don't have the comma at the top, okay? So our transformation matrix becomes A0, 0, 1. Now, translation is very simple. If I am translating 2 units right, you just chuck a 2 here on the x-axis. If I'm translating 1 unit left, you just put a -1 here. So it only has an impact on the x value. So this is simple addition and subtraction because we're not dealing with the multiplication part that comes with the more complicated reflections and dilations. And then if I'm moving up and down the y-axis, obviously if I'm moving down, I'll have like a negative, and if I'm moving up, it'll be plus something, okay? So let's go through some examples.